Hello. Hi. Hey, yes, I'm Cheuk. So. Before I really go into the talk, that usually I ask people well, you know the title of the talk, you come here, so definitely you're not fond of writing tests, right? So what is the most difficult part of writing tests? So what makes you not like writing tests, right? Any ideas? Examples? Wow, that's really good. I really feel you because that's also something I'm going to tell you later. A lot of things. Sometimes you kind of forget where you put the test. Because if you are good, if you want to make your code coverage, the test coverage to be high, right? You have to write a lot of tests, and sometimes it just get too messy because there's too many tests, and you have to try to cover all grounds. But talking about cover all grounds, you need a lot of examples, right? So that's exactly what the other person said, right? Thinking about what to test, thinking about the test cases, thinking about what example to give to the test. That really tripped me over. So hypothesis probably can't help you with importing the code, right? It's don't mess up the path of your code. Try to you can find a solution on Stack Overflow probably. You need to have to init the py somewhere, things like that. But hypothesis that help you with organizing your tests, where you see why in a bit, and also it will help you to think of, well, not really help you to think of test case, probably with using hypothesis you don't have to think of writing test cases. So how do we achieve that? So this is the topic of this talk, right? How to avoid all the pain of writing tests. So first of all, I would like to introduce myself because it's the first time I'm speaking in this city, in New York. I'm Cheuk. Hello. I work on Anaconda, and I love open source project. I've been involved in different open source projects in the past. That's why I do a lot of testing, and some of them really it's a pain. Also, I organize events. I also organize not this year, but in the past I organized PyData Global. I also help PyData London, so it's my local PyData. I'm based in London, UK, so yeah, it's very rare for me to be here, so I'm so happy. Also, I organize an online conference, which I will tell you at the end of the talk. Sorry, I'm too excited. Also I stream online a bit, but not now, during the pandemic. Past. So, have you heard of property-based testing? Yes, some of you. So what is property-based testing? Well, it's a term, right? Are you creating it just to sound smart? No. So to make it simple, so we test there are actually multiple ways of testing. So you may have been told that you have to write unit tests, right? You have to test each function, each method thoroughly. So I will draw a line here, and I have two ways of doing it. So one is test by sample, one is test by property. So I would say that normally how we write tests is test by example. So when you think of what to test, so you have to think of test case, right? We also have to provide example for the test. We have to imagine what that variable could be, what the input of the function could be, so we have to provide example. The other thing is the property-based testing, which we don't have to think of what it could be, it's what it is. So for example, if you have a function, the input is 2 integers. So the inputs are 2 integers. That's what it is. You don't have to think of, oh, so what is an integer? Is it 0? Can I test? Do I have to test 0? Do I test negative? Are they just positive or negative? Do I test a very large integer? So you don't have to think of that. It's just given. So because of that, if we test by example, we have to think of all the test cases. Again, like the thought process, right? Do I test 0 or not? Do I test minus? Do I test like very big numbers with brick? So you have to find the edge case by yourself. But with property-based testing, those work actually has been lifted, has been done from the strategy in the library. So I'll talk more about strategy in a bit, but that's why you don't have to think of what example to give. The other thing is like edge case, right? We all know that edge case are the things that we have to test, because that's usually where we overlooked, where we like, oh, forgot to test a 0, right? So, and then like you just divide the number and then, oh, divide by 0 error. When usually the user find it out themselves, you kind of feel a little bit embarrassed that you forgot to test the 0, those things. But with property-based testing, because the strategy has been used so many times, and I won't say it's like bulletproof, but like the chances are you having this is way less than you think of, for example, yourself. So how does hypothesis make that happen? It sounds like magic. I don't have to think of anything. So in hypothesis, first of all, we use a lot of decorators. One of the most common ways to introduce hypothesis to your test is to use given. So given is a decorator provided by hypothesis. That it acts as an entry point, so it will modify your test into a property-based test. And then you also need strategy. So strategy is basically the heart of the property-based testing. It basically describes how to generate the test case. So this is why you don't have to think of it yourself, because the strategy is already written by someone and it's helping you because it has been used like all the time. So I hope the strategy is going to be like kind of more thorough than like what you kind of think of a few use case, test case yourself. So strategy is going to generate the test data for you. So this is a one-on-one example of how a hypothesis test could work. So this is a very simple code that is, I think is an example from somewhere, some library, other libraries that basically it's doing a very simple thing. It got a string, and then this encode function is encoded, right? And there's another function that's decode, so decode what has been encoded, so it will go back to what it was. So simple, right? So we test it. We use hypothesis. So like I talked about before, we need a given, which is decorated to act as an entry point to your test. So given, we have to import it, and then we have to import a strategy. Since the encode function is encoding a string, so it's text. So the strategy that we use is the text strategy. So we import those things, and then just add the decorator like that. It's a given, and then we have one input. The input is a text. So that's how it looks like. So the whole thing looks like this, very simple, 7 lines of code. Also, the way we test it is what we call the round trip. So because we have a pair function, encode and decode, so if you have a string, you encode it, and then decode it again, it should come back to what it was. So this is what it's testing, right? All good. So how about we try it? So let's try it before we move on. So sorry, not this one. Okay, still a bit funky. Okay. So what I've done is I've already done some prep work. I've created a mycode.py. So let's have a look at mycode.py. So sorry about it's not highlighting. I should add some plugin there, but bear with me. It's basically the same code as I showed you in the slides before. So we have encoding and decoding, so that's my code. So I want to test it, right? So I've written the test, so I copy and paste the test in the test.py. So let's clear it up first, and then let's have a look. Oh, wow, it's very loud. Okay. Oh, no, I think I put an S. Yeah, I just name it randomly, sorry. Yeah, so just import the code and then test it, right? So, very straightforward. Let's run it. So in this environment, you can see it's called demo hypothesis, which it got hypothesis inside. So I use PyTest. So let's use PyTest and then test the code. Oops, doing this again. Okay. Whoop. We have an error. But don't worry, I'm expecting this. So what happened? I know it's a bit difficult to see, but maybe someone sitting in the front already know what's going on. No? Maybe it's too difficult to see, I know. The red thing is like basically hiding in the background. So it says, so the error says local variable character reference before assignment. And then the important thing is that like after that it says that it fails on the test case that when the input string is empty. So we found an edge case that it fails. Yeah, when the input string is empty, then we have a problem. So as you can see, what we have done is just that we write several lines of code. We haven't think of what cases to test, but we already found an edge case that we may have to fix in our code. So this is the power of hypothesis, that we don't have to think of like what string to test. Do we test string of length 1, string of length 2, empty string? No. It will just find all the case we used to test, and it will help you to find things like this, right? Good. Let me go back to the slides. Okay, cool. So, there's already a question. Do you mind if you hold on until the end?
Yeah, no.
Okay, yeah. So, I know for those of you who come to PyData New York, you're interested in like scientific programming because data science also uses a lot of scientific things. So what I talk about scientific stack here is actually NumPy and pandas. So in NumPy, so they're actually, why I talk about this in this conference is that I think now hypothesis got a lot of, because it has the user in mind, right? So like kind of think of people who use NumPy or pandas, the other strategy may not be very useful for them because NumPy got its own type, it got its own D type that is like some integers or unsigned integers, all these things, right? Scientific scalars, and also arrays. We have NumPy arrays and stuff. So don't worry, hypothesis got you covered. But the thing is, because hypothesis want to keep its library light, not all users are using NumPy like us, right? So you may have to install hypothesis again if you already have it, or if you haven't installed hypothesis, you're going to use NumPy, you can install hypothesis like this. The difference is that it will install that NumPy extra for you. So it will so you can use what I'm going to talk about in this slide and the next slide. So after you have installed it like this, so you will have some extra things at the hypothesis.extra.numpy. So you can use the strategy there. So if you look at the documentation, you will see that there are lots of strategy provided for some like NumPy specific types. For example, there are detail can maybe actually I can show you this thing if it works. Yes. So there are lots of different types that you can see here. They are like, for example, the arrays, the NumPy arrays. So now, like, in a Python object, you can test like, oh, the text, test the list, but it doesn't apply to NumPy arrays. So now you can have the NumPy array strategies that it will work. There's just an example showing you how this works. And there's also other scalar types, like for example, you can have the integer and unsigned integer, all this stuff. So these are built extra for NumPy users. So you can have some extra strategy to help you, because otherwise it's kind of quite useless, right? You have all these, NumPy things that actually, well, I don't know what strategy to make it work, or you have to come up with your own strategy, which is a bit more work than what you're expecting, right? Let's go back here. But on top of that, right? So maybe you think like, oh, NumPy is cool, but I am handling data. I'm like cleaning data or something. So I use Panda more than NumPy. So we also got you covered, don't worry. So it's the same thing, you have to install the extra. You know that pandas actually use NumPy under the hood, so it's more or less the same thing, you have to install it like this. And then we have the extra stuff under pandas. And what it provides is the pandas index, pandas series, and pandas data frame. So pandas data frame is, well, we all know, right? It's like the DF, right? Like we have all these like shorthand that only data scientists understand, like PD is pandas and NP is NumPy and DF is data frame. So the data frame, so actually it's pandas data frame. You can also find a strategy for it very easily. Also series. Series is basically the building block of data frame, so you can build each column as a series. And panda index. Index is like it's quite important for data frame as well, because like that's how you find all the columns and all the rows. So those are also available. So you may like, for example, like you have never thought that hypothesis is going to be useful. Now, with this information, you can, oh, maybe I can try it on my pandas data frame to see like you can find all the edge case or maybe an empty data frame. I don't know. Like maybe you have to put in the shape of it. I forgot like how it looks like, but again, it's in the documentation. If you go back here, so yeah, I do believe the array you have to put in the shape of it. But like for example, you also have the pandas. So if you scroll all the way down, there's all the pandas. It's also available. Let's look at maybe the data frame. If they have any. You can even test the columns, right? It's even like I want to see if this works for all these like different columns. So you can try it that. So yeah, so you can read that. I'm not going to go to the details, otherwise like we're gonna be reading it together for the rest of the talk. So let's go back here. Sorry, I've been using Mac for so long, but I'm still like finding it quite tricky. Okay. So far so good, right? So far we know that there's a hypothesis. We have things that like we could test with, like we have a string, we can test it with the strategy that's text. We have a NumPy array, we can test it with the strategy that's like, or from the array type of this thing. But what if I'm really lazy? But that is even too much for me. I have to think of what strategy to use, right? It's too much. It's too much. I hate doing that. So what am I going to do? So first of all, a piece of advice, even if you're super lazy, it's always good to type your code, because it will also avoid making a lot of mistakes, but at the same time, it really helps you here. So, do you know that in hypothesis, there's something called a ghostwriter that actually literally write the test for you. So you don't even need to write the test. So if you're that lazy, that doesn't really help you. So what a ghostwriter do in hypothesis is that it will use typing as a hint. So that's why I said typing is important here. Later on, I'll explain why, what happens if you don't type your code. But if you have typed your code, hypothesis will pick the right strategy for you from the type of your parameter. So again, sometimes things are quite straightforward. For example, if you have a string, you just pick the text strategy. If you have a NumPy array, it will pick the right strategy for you if you have the NumPy extra. So with the typing, because you have told the program that what type your variable should be, Ghostwriter will pick that up and write the test with the right strategy for you. So it's a CLI tool actually. So actually you can use it in a Python code, but I think the most powerful thing is to use it in a CLI tool. So I will show you a bit of how it could be done in a second. I'm just going to finish this slide first. So also, there's like Do you know the formatted black? Yes. Yeah. Now everybody use black. No, like a few years ago it's still new, but now everybody use it. So if you have black installed, it's not a hard requirement, but if you have the black installed, the ghostwriter will finish writing your code and it will format the code for you using black. So if you like the format that black provides, it will be consistent. The ghostwriter, the text that ghostwriter writes is going to follow the same format as well. So this is how it works. It's just like this. So let's see how it works in the terminal. So, oops. Okay. So let's see how it works. Right. gzip. I think that's what it says. Oh, what happened here? So actually, this is color coded. I'm like very puzzled. I don't know what happened. I think it's because like it's the output from Hypothesis. That's why it's so nice. It's color coded. It's even color coded. I don't even pay attention to that. Okay. Anyway, so this is basically all the text that's generated by the ghostwriter. So yeah, you can see from the comment here, it's maybe difficult to see. Test code was written by Hypothesis. Yes, it's written by the ghostwriter. So what I've done in this CLI is that I said that I want to write the test for the module gzip. So gzip, for those of you who have never heard about that before, is a standard library, which means that it comes with your Python. So you don't have to pip install it. You probably will already have gzip, so you can write tests for it. This is actually a test, right? You import gzip, it import all the strategy and the given from Hypothesis. It write the test. So these are all like a Hypothesis test, right? You got the given, you got the strategy inside, and also there are different way of testing as well. There's like you can see we have a round trip. So this is similar to what we have done manually before, which is like doing a compression and doing decompression, see if they are the same. There are also other things like, for example, fuzz, which just means that I'm going to run the function to see if it works, if there's any error that comes out. Yeah, so it's very, I would say this is covering all of the tests, well, maybe not all, but most of the tests in gzip. So I have not even written a single line of code. What I've done is just to type in a command line. So there's actually a lot of settings you can set. So for example, here you see that so this is the examples you put in a module. So gzip, like I said, is already included. So you can have that. So you can also like run the whole module, but you can accept something. For example, I don't want to test all the errors from RE, so you can skip that. You can also pick different strategy for the ghost. So there's like different ghostwriter strategy there. So I'll explain that a little bit. So you can also pick different ones. For example, round trip is the one that we've tried. So yeah, you can see all this explanation here. But let's go back to the slides. Right. So there are actually different ghostwriter strategy here. First, you have seen it in the gzip example. It's just kind of run the module, the function in the module to see if it works, or does it provide any errors. So this is what it does. Yeah. The most basic one, if you ask me. So, but there are other different things. It's more interesting. For example, this one, it just means that if you apply a function to a result, it is a definite result. You can apply the same function to the result of that again, but it won't change. So it's useful when you test something like sorting. So if you sort something, it should be done, right? If you sort it again, it should not give you something different, otherwise that's random. Sorry, it should not be like that. So, so for those kind of function, you can test it with the yeah, I don't know how to pronounce this word. It's so difficult. So you can use this strategy to test a function like the sorting algorithm. So round trip, which is my favorite, you can see I already used it a few times already. When you have a pair of function, it will apply the first one to it, and then applies the second one to it. It should go back to where it was. There are actually, in code, there are actually a lot of pairs of functions like this. For example, in JSON, you have the JSON dumps and JSON loads. Well, I use it a lot because I handle data, so there's lots of JSON coming in and out. So that's really good. Sometimes I write my own function to handle some data handling, like to switch it from one format to the other, and then going back. So you would write lots of pair of functions like this. This is super useful when you don't want to write tests for it. You can just generate a test for it. So oh, by the way, also go back here. Remember when we do the gzip, right? So when we do the gzip module, so we just put in the name of the module. So what the ghostwriter does is that it will scan the whole module, and if it finds two things, that the name is hinted that they are paired, for example, dumps and loads, or from something to something, then it will just automatically apply round trip to it. So in the gzip, I think that was compress and decompress. So the ghostwriter already see those two and know that it's a pair that you can test it with round trip. So that's how powerful the ghostwriter is. So the other thing we can test is the equivalent. For example, you have two functions. You can check whether they more or less behave the same way. This is useful, especially when you already have one function that you know it works. For example, it's provided from the standard library, like this one here. I made this up myself. So I want to write a function that does the mathematics, right? I will check whether this is the power of this. So it should, if I do it correctly, which I don't think I do here, but anyway, if I do it correctly, it should actually be more or less the same as the method of power, right? Because I know that method of power is going to be correct, but I want to write my own, sometimes for different reasons. Sometimes you may want to have a speed up, or sometimes you have, different reasons that like, oh, that's optimized for my code or things like that. You write that, you want to check whether it behaves correctly. You can use a function that you trust to check it against that one. So there's a lot. There's a lot of ghostwriter. There's actually two more, but I won't dive into detail here. There's one that tests for a binary operation, but because I don't know about you, but I personally don't write custom binary operation that often, so I'm not going to dive into it. Also ufunc, so if you use NumPy, it also has the ufunc to test the array ufunc for you, NumPy array ufunc for you, so it's useful if you use NumPy, but I won't go into the detail. You can check the documentation if you really want to know. So, I've already done this bit, actually I've already tried it, so I'm not going to do it again, but, or maybe let's try one more thing. There's one thing I want to try. For example, I want to try the JSON one, because like I've shown you the round trip, right? So what we do is like just hypothesis, right? So I do JSON. Oh, actually, I will show you a few things. Actually, I completely forgot. I'm still having jet lag. Sorry about that. So this is JSON. You can see that it does test the round trip, right? I hope it does. So there's a lot of things to test actually in the JSON. So yeah, round trip. So you see dumps and loads. So it knows that it's a pair. I don't even tell like ghostwriter that, oh, there's dumps and load in JSON, please test them round trip. I don't even need to say that. It just have a very smart guess of it should be tested this way. Also, it tests other things. For example, there's an error I should actually accept, like I should skip that, but it happens. So yeah, so it's very cool. So what I want to try to show you is that since now I have the my code, right? So let's have a look again. So my code. So this, right? There's an example at the beginning of the talk. Now, imagine I don't want to write my own test. I'm so lazy. So what am I going to do with this? What I'm going to do is to use Ghostwriter. So let's look at this again. So yeah, I have my code.py, so I have to treat it like a module. So what I'm going to do is to do just hypothesis. Oh. Oh. Write my code. Yeah, I think my jet lag is really gripping on me right now. I'm so sorry. I'm so tired. Okay, so beware that don't type .py at the end because it needs to be treated as a module. So now I have my code here. It will be like a local module. So I don't type .py. Otherwise, it's a file. Press enter. So this is what the Ghostwriter generates. In my opinion, this is even better than the code I write because because it's like very, very clear, right? And then also color coded is amazing. Wow. Okay, so but this is actually more or less the same thing. It's a round trip test. It's testing the code that the first thing is to have the input string as the input, and the second is to use the result, which is value 0, and test it as the input for the second one, and it got the value 1, and the value 1 should go back to what the input string should be, right? So it's exactly like what we did. So so imagine, okay, so how am I going to use this now? So because this is generated and it's in the command line prompts, how am I going to use it? So what you can do is to, I believe, it's like this, right? Save test. Let's name it something else so I don't mess up. Okay, it's like this. I think it's like this. Okay, right. So now I have an extra file, save test. So this is exactly what is come out from the command line prompt. Now I can run it with PyTest, right? So I will PyTest, and then I will save test. So it's exactly the same thing that we got before. So if you haven't seen the example, like the demonstration at the beginning of the talk, you will see that I have run the test without writing the test. This is what I try to show, that with hypothesis you don't have to write the test. Okay. So it's really cool. But I always leave you with a but, something to think about. It's nice as if I'm really kind of preaching you to please use hypothesis. I know that sometimes there's a few catches and it's not always 100% like you must do it. Something you have to think about when you use hypothesis. There's always a trade-off. One thing that why hypothesis is not even more popular than what it is right now is that tests can be slower if you have a massive library like scikit-learn. So, because then you have to generate a lot of strategies and you have to. So it's not even easy to write the test anymore because you can use the Ghostwriter to help you a little bit, but sometimes you still have to fine-tune the strategy and stuff. So it will be a lot of work, and the test can be much slower because instead of having 3 cases to test, I have to generate them through hypothesis. So it could be slower. So also tests can be harder to understand. What it means is that in for example, instead of using hypothesis, I use PyTest.parameterize. So in parameterize, it's very straightforward. I have 2 input, x and y. So x is 1, 2, 3. Y is 3, 2, 1. So it's you can see very straightforward. I test the case, all this stuff. But for hypothesis, you don't write it out. You just x is an integer, y is an integer. And what is tested, I'm not so sure, but I just trust hypothesis do it. And it could be difficult for someone to want to look at the cases by cases, right? You can actually use a hypothesis to say that I definitely need to test, for example, x to be 0 and y to be 0, right? That's what I definitely have to test. You can do that, but if you're just writing it like what I've shown you earlier, just using strategies, then that would be more hidden, what I've done. Also, if you don't use typing on your code, you can't really use the ghostwriter to the fullest, because what ghostwriter would tell you, so instead of like, oh, I use the strategy as test, right? So this bit, what hypothesis would say is like using nothing, which is definitely, well, you need to test something, right? It's not testing nothing. So you have to find the strategy and replace the nothing here yourself. So it's not the most efficient way to using it. Oh, I ended very abruptly, sorry about that. So, so that's, you have to think about when you use hypothesis. And, but I think in generally, like, give it a try. If you, for example, when you just started a small project, the code base is still small, try to see if it helps, try if it saves you time. If you get used to it, maybe you would love to use it more. So that's it from about hypothesis. Last slide is about the online conference, PyJavaSCon. It's happening at the end of this month. I know it's the Thanksgiving weekend, but if you have nothing else to do, if you're sitting at home, this is the perfect way of spending your holiday. And it's free. It's free, right? Just sit on the couch and it's free. And you can learn Python. Okay, so that's the end of this talk. Thank you so much for sitting through it. I think a little bit of time for questions. I know there was one question at least. No? Okay.
So, is there a way of parameterizing like how many different things to test? Because I can imagine, depending on how much compute or time you want to have as a budget for the testing, it's like, okay, spot check a few things versus like try 1,000 different kinds of integer combinations.
Yeah, so actually, shall I dive into the very like rabbit hole of the source code? Okay, a homework for you. So if you go to see the source code of Hypothesis, you will see that for strategy, they actually doesn't go too crazy about like it would, because the strategy has been written and has been tested by a lot of different engineers. So, for example, I can tell you the integer. I think they test, the string, the test that is here. They test the empty string. They test maybe a string with one character, and then a string with two characters. And because 1 and 2 pass, so it just assume that 2 plus 1 also pass, so it won't test infinite amount of things. Of course you can challenge it, of course you can think that like, this strategy is not good, you can either customize it or you can even improve the strategy and make a pull request to change it for everybody else. But but like for simple things, it's already designed that like, I'm not randomly testing many things, but I'm testing, that's why it's called strategy. It's like picking the things to test that it's more prone to overlook. But yeah, that's like strategy is a very complicated topic. I think like for an introductory talk, I can't go into detail, but definitely check out the documentation, check it out yourself, and yeah.
Yeah, so I cannot courtesy that you're from Anaconda, one that's pivot development. And I can see this, not the latest one within the repo, within the default for Conda ages ago. So I'm curious why not.
Well, I'm just like, I'm not like blindly saying that you must use Conda, right? I know Conda is. Well, you can also, Conda well, even if you're using Conda, you can still pivot install things, right? So you can either, Conda install or you can pivot install it. I think the main difference is that Conda is using the Conda repo, so it's like more secure and stuff. So, I'm not like crazy saying like you must use Conda. So, yeah.
So for the round trip test, does it test for each single trip? So for example, decode and encode, what if like encode just return the exact copy of your input and your decode also return the exact copy of your input? Would that pass the test or fail the test?
So you mean the round trip, for example, in the example here, if I write another encode and decode and it's just like return whatever it is, it do nothing, it will still work unless, you know, if, because the thing is, the bug here is that when it's an empty string, it would have, I think because it returns something that is like, it's not been defined or something because of the check. I haven't go into detail, but the problem is that because when it's empty string, then like basically something happened that some variable is not defined somehow. So if you just like do nothing, I think the chance of making a mistake is very low, and I think that you will pass on the test because, well, it does nothing, so it's perfect. In that case, it doesn't know that it doesn't do nothing, so.
Yeah, I guess what I meant is that does it test whether encode give you the expected output, or would it only test it after the two functions testing?
Yeah, in that case, for example, JSON loads and JSON dumps, right? That's all we know about that, so it's easier to explain. So the hypothesis doesn't check that like, oh, you have a string and you have dictionary and you put it in the JSON loads, JSON dumps. Does it come out as a perfect, correct, parsed JSON string? No, it doesn't. It's just, you know, the ghostwriter is just kind of taking some shortcut that if you encode and decode it, it will go back to what it was. If both of them are wrong, if both of them kind of wrong at the same time that it makes it go back to the original, it won't pick it up with the round trip. So that's some blind spot in there. But yeah, it's not perfect. If you want to check whether